Hello, welcome back. Let's look at probabilities with Venn diagrams when we are given the count in each region. In this scenario, we're told that we have a class of 30 students. 19 of these students study physics. 17 of these students study chemistry. Whoa, let's just stop right there. Hang on. 19 study physics at plus 17 study chemistry. Isn't that 36 students? More than the number of students? Oh, right. This is the total number of students that study physics. So some of these students also study chemistry. Okay, cool. Anyway, 19 study physics, 17 study chemistry, and 15 study both subjects. We want to display this in a Venn diagram. Notice that I'm given the count. I'm given how many are in these categories. So again, let's draw a big rectangle to represent the entire class of students. We'll draw a circle to represent the students that study physics and a circle to represent the students that study chemistry. We will label them with physics and chemistry. You could be lazy and do a P and a C. That would be fine, as long as it is clear what you mean. And now I can put in some of this information. We know that 15 students study both subjects. So 15 students are in this region where they study physics, they're part of the physics circle, and they also study chemistry, they're part of the chemistry circle. How many students only study physics? Well, there are 19 students who study physics. So out of these 19 students in this circle, out of these 19, 15 of them also study chemistry. How many are left in here? There are 19 in the physics circle, minus 15 who also study chemistry, which means that there are 4 left over. Let's just double check. The size of this physics circle is 4, the size of this region, plus 15, which is the size of this region, which is 19. Cool. So 19 students study physics. We can do the same for the chemistry side. There are 17 students who study chemistry. 17 students in this blue circle. 17 students. And 15 of them are here. So how many of them are in this part of the circle? 17, take 15, is 2 students left over who only study chemistry and don't study physics. Finally, we can start to think of the leftover category. How many don't study physics or chemistry? Well, there are 30 students in the class, minus there are 4 in this region, minus 15 in this region, minus 2 in this region, which is 9 students. Let's just double check that this works. We already checked physics. Let's check chemistry. 15 plus 2 is 17 students study chemistry. Good. 15 students study both subjects. Yes, there's a 15 in the intersection of both subjects. And the total number of students, 4 plus 15 is 19, plus 2 is 21, plus 9 equals 30. Good, so we can check that this diagram matches this information. Now we can look at probabilities. For example, what is the probability that a randomly selected student does exactly one out of the 2 subjects? So the probability of physics or chemistry, but not both, is, well, it will be these 4 students that only study physics, plus these 2 students that only study chemistry. So there are 6 students who study exactly one subject. Why don't these students count? These 15 students study both subjects, and we want the ones that just study one subject. So 6 students out of 30, and we can simplify that to be 1 out of 5 by dividing them both by 6. Okay, now let's do a given that question. So given that a student does not study physics, determine the probability that the student studies chemistry. Okay, so we're only looking at the students who do not study physics. So imagine, I wouldn't scribble this on your paper by the way, but imagine that all of these physics students are gone. They do not exist. None of these physics students exist anymore. Imagine that world. Okay, cool. I don't know how we're going to get any engineering done, but they are gone. So out of the students who don't study physics, you can see I've tried to illustrate it in this diagram, out of all the other students, so all these students that don't do either subject or the students who just do chemistry, how many of these study chemistry? There are 2 students of this remaining group that study, out of these 11, so there are 11 students in total, 2 plus 9, 11 students that don't study physics. And out of these 11 students, 2 of these 11 students study chemistry. So therefore, and I've introduced you to a new notation here, a new way of writing things. This line means given that. And this reads as, therefore, the probability of chemistry, given that it's not physics. This apostrophe is the complement, which means not that event. And this line means given that. So the probability that a student does chemistry, given that they do not do physics, is 2 out of 11. You can see this notation, although it's tricky to think about at first and tricky to learn, it's really, really concise. Like, it's so powerful that you can say something really powerful, like this whole question, this whole sentence is just this. Maths is amazing sometimes, how condensed things can be. Anyway, so that is how you can do a given that question. You look at only the students that match this given that condition, so only the students who don't study physics, and out of these 11 students, 2 study chemistry, so it's 2 out of 11. I hope this has been helpful. Sometimes drawing diagrams like this can help as well. Or sometimes you can use your hand to block out this group of students you're ignoring. But I hope this has been helpful to learn how to do probabilities with Venn diagrams when you're given the count in each region. Ask me questions, I'm here to help. And good luck with the questions. Bye everyone.